Hi, my name is Kevin James, and let's talk about Linux signals, what they are and how you use them. Linux signals. Signals are one of the several different inter-process communications that are used in the Linux operating system. Inter-process communications are methods that processes can use to communicate with each other and also with the kernel to coordinate their activities. There are several inter-process communications that Linux supports. And although we're only going to talk about signals here, you should be aware that there are several different types of IPC, inter-process communication, available in Linux. You can see this in the following slides. Signals, which are sent by processes or kernel and meant for a specific process to indicate a condition of some form. Pipes. Unnamed pipes are set up by the shell. A common use is to use the pipe character to send output from one program to the input of another. FIFOs. Named pipes, which operate as first data in, first data out, hence the FIFO in the name, first in, first out. Message queues. Message queues are a mechanism that allows one or several processes to create messages that can be read by one or more other processes. There are several types. Semaphores. Semaphores are a method that's used to control access to shared resources. They're used as a locking mechanism to prevent more than one process from using a resource at any one time. Shared memory. This is an area of memory to be shared by multiple processes. So what's a signal? Signals are sent by processes or the kernel and meant for a specific process to indicate a condition of some form. Basically, a signal is a software interrupt. You may not be aware of it, but many of the day-to-day tasks you will perform on a Linux server make use of signals. Some examples. Control-C. When you're running a script or a process in the shell and you press the Control-C combination, a signal called SIGINT is sent to the process that's running, and provided the signal isn't being intercepted by a handler in the code, then your program will stop. Control-Z is the suspend signal. It sends a signal to the running program or script in the shell. It's a signal type of SIG TSTP, and this allows you to get back to the shell. You can then use the BG or background command to move it to the background and let it run, or use the FG to bring it back to the foreground, in which case you can cancel it or stop it or do whatever you need to do with it. Let's see an example of Control-Z. Let's have a look at the Control-Z command. Now I already have a program here called Simple Loop, and all it does really is just do a simple loop. So let's run that program. And that's pretty much all it does. But let's see what happens if I do a Control-Z. It says stopped, and it's come back. The program hasn't actually ended, it's just paused for the moment. Now I can have it running again. I can just go BJ, which is the background command for the most recent program, and it's running again. But well, I can use the kill command, which we'll talk about in a minute, to stop the program. It's better to bring it back to the foreground, and I can kill it from there. And as we can see, the program is still running. So let's use the Control-C, and the program has ended. Some examples of day-to-day commands that make use of signals. The kill command. The kill command combined with the PID, the process ID of a running process, will by default send that process the sig term signal, which will tell that process to terminate. This is the default for the kill command. You can also specify the signal to send to the process. For example, a common use would be to send the sig kill signal, which would force the kernel to terminate the running process in an unclean manner. Let's see an example. So let's use an example of the kill command. We have our program, Simple Loop, which again, all it does is loop, but the program actually has some code which tells you what the process ID is, and we'll make use of that in the kill command. You see that the PID is 8489, so let's kill it. And we'll use the 9 signal, which is the terminate with extreme prejudice command. Well, if we go back, we'll see that it has killed. There it is, it has killed. Now, some signals can't be handled in code, and the reason for that is because the kernel's handling them and not the code itself. Now you have the sigkill command, which is similar to a -9. This kills the process. It's a harsh kill. It's not a very nice way to stop a program, but sometimes you have to. you have a sig stop, which stops the specified process. And the sig stop is, you can use, that's the control C. Note, you can use a sig cont to resume the process, which is a different signal number. Here is a list of the first 20 signals available in Linux. You can see you have the numbers assigned to them as well, and those numbers are used. You could use those numbers with the kill command. And you can get a list of the available signals with the kill command. You just add the option L to it. Let's see an example of that. Now, on a running Linux system, you can find the list of signals that are available by using the -L option on the kill command, as shown. Those are all the signals that are available to you. Now, if you want more information on the kill itself, then the manual command is always useful. As you can see, I highly recommend going through there and having a look. Thank you for joining me on this brief training for Linux signals. There are extra resources on the internet if you want more information. I would suggest Wikipedia is a good site to go to. Also Google or other search engines. If you have any questions about this training or for more information, please contact me, kjames@learnredhat.com. Thank you and have a great day.